Hello dear students, another question, AQ exam question on electricity current. So here we have three identical cells, each of internal resistance R are connected in series with the external resistor R, and the current is the external resistance is such. If one of the cell is reversed in the circuit, what is the new current in the external circuit? Okay, now the scenario is we have three EMF, three batteries which has internal resistance R. All the three cells have internal resistance R. All the three cells have internal resistance R, and the external resistance also R, that is connected across the external circuit. Okay, and now we have to find if we one of the battery is reversed, terminal is reversed, what is going to happen. So what is the new current in this case? Okay, first we find the current in the previous case, total current in the previous case. So if I is the current flowing through the external resistance I, so the current I is equal to, as we know that the current is equal to total potential difference, total EMF divided by total resistance. As we know that in the previous case the total EMF is the sum of all potentials, because you know that the current is going from negative terminal. If we took the direction from negative terminal towards the positive terminal, so or from positive term, sorry, we have to, if we took the direction from positive terminal to the negative terminal. Okay, so as we know that the current is, so according to KVL, Kirchhoff voltage law, so if according to KVL, so when we move from negative terminal towards the positive terminal, so the battery EMF value is positive, the potential drop is plus E. So the total EMF will be the sum of all potentials. As you know that three identical cells have the same EMF, mean the E1 is equal to E2 is equal to E3 is equal to E. So all the cells have the same potential. So that in the previous case, in the first circuit diagram, the potential is, total sum of potentials is E1 plus E2 plus E3, that is E plus E plus E. And the total resistance is, as we know that each component, mean the three batteries and the R, has resistance R. So the total resistance is R plus R plus R plus R. So that the total resistance is 4R. Total resistance is 4R. So we divide and then we get the current, that is equal to I is equal to 3 EMF over 4R. So this is the total current I in the previous case. Now we change when we reverse the battery E1. So when we reverse the battery E1, so now we took the direction from this end towards this end. So current I dash is equal to, now the new current in the external circuit R is, we start from E3. So E3 is from, as we know that when we move from negative terminal towards the positive. So E3 is positive plus E plus, as we know when we move through E2 is again negative to positive terminal, we're moving, so this is also plus. But when we move from E1, so that is from plus to minus. As we move from plus to minus, according to KVL, this direction or this EMF will be negative, minus E, and we divide with the 4R. Total resistance is again 4R. So the one of the EMF will be cancelled, so we are left with the E dash, that is equal to E over 4R. So E dash is equal to E over 4R. So if we compare these two currents, initial current I and the final current I dash, so we compare these two currents, comparing I and I dash. So we are left with the, you know that the I and I dash, I is equal to, I over I dash is equal to, or I dash over I is equal to, if we took the ratio, for example, I dash over I is equal to E over 3R, E over 4R, divide with the 3E over 4R. So E will be cancelled, 4R will be cancelled, we are left with the 1 over 3. So we can just find I dash new current, that is equal to I over 3. So the new current is the 1/3 of the original current, 1/3 of the original current I. So that our answer will be A part. A is the correct option. Okay, so our new current will be I over 3. Okay, thank you. So actually when we reverse this EMF, so this EMF will be negative, so one EMF will be cancelled, so we are left with the E over 4R. So when we compare I and I dash, so we get I dash is equal to I over 3. So the current reduces to 1/3. So correct option is point A, option A. Okay, thank you.